Hey, welcome back to Math with Patrick. Today's November 17th, and we're solving problem 321 from the Daily Epsilon calendar. And x should be 17 today because that's today's date. So let's try to figure out what x is, and maybe along the way, if we find out what y is, that's not too bad either. So we have two equations, two unknowns. We are set and ready to hopefully solve for both. X minus 2 is equal to 3 times y minus 2. And then x minus 5 is equal to 6 times y minus 5. All right. One idea that I have at the start is maybe we could do this kind of interesting change of variable stuff. As in if I say that a is equal to x minus 2 and then b is equal to y minus 2, then we could kind of simplify these equations. And you know what? I'm all for kind of interesting ways to solve problems. So let's go ahead and see what happens here. The point is that if we do the substitution, I'm essentially just choosing, let's say, okay, we know that x is supposed to be 17. So this is just me solving for 15 instead of 17. And then once I do all this math and figure out that a is 15, I can just plug in a 15 in this equation and show that x is 17. And the reason why I'm even doing this is because it kind of makes this beginning equation, this first one, a little bit simpler, right? We're kind of doing away with this minus 2 business. And then on the right side, okay, I guess x minus 5, if a is equal to x minus 2, I would need to subtract 3 from both sides to get an expression that matches x minus 5. And so I'm not really making this right side equation that much better, but whatever. This is going to be the same thing as a minus 3 is equal to 6 times, and then for the same reason, y minus 3. Nope, b minus 3. My bad. Maybe this is useful because now we have just a direct substitution here. We could replace a with 3b and then solve for b. So 3b minus 3 is equal to, let's distribute this, 6b minus 18. Let's maybe subtract 3b from both sides, add that 18 to the other side, and so we get b is equal to 5. That's cool. So I guess that shows us if this is 5, then y needs to be 7. And then I guess if this is 5, then a would be 15. Hey, there it is, right? That's what I was saying earlier. And then if a is 15, x would need to be 17. So I guess that works. We could change the variable and at least make one of the equations a little bit simpler. The other way to solve this probably would just be expanding everything and then just setting up a system of two equations. So why not? Let's try that. We get x minus 2 is equal to 3y minus 6. And then x minus 5 is equal to 6y minus 30. We could eliminate the x variable. So if I subtract an x minus 5 from the left, that would be the same thing as subtracting a 6y minus 30 from the right, again, because one of our equations says that these two values are equal. So x minus x gives us nothing. Negative 2 minus negative 5 is 3. 3y minus 6y is negative 3y. And then negative 6 minus negative 30 is 24. We can maybe add the 3y to the other side, subtract the 3 to this side, and so we do get y is equal to 7. And that's kind of where I got, or this is kind of the same part in the solving process as getting that b equals 5, right? We kind of had to solve for b or y first. At least that's how it was easiest for me. And then using that information about what we knew about b or y, we could then plug it back in and figure out some stuff about a or x. So I guess that's about it. It's just a system of equations. You could even graph it too, and I think you'd just see the answer where the lines intersect. And so there's a lot of different ways that you can solve problems like this. Either way, I think we can be pretty confident that x is 17 and only 17, and we're all done for today. So thank you for watching, and I'll see you tomorrow. Bye.